So Unit 4, Digital Logic Circuits, Asynchronous Sequential Circuit and Programmable Logic Devices. That's some triple E. So this is the topic is asynchronous sequential circuits. So we know that what is asynchronous sequential circuit. So asynchronous sequential circuits, that a combinational circuit, it output depends upon only present input. But asynchronous sequential circuits, especially the sequential circuit, the output depends upon not only present input, also the past out. The past output they will be get it from that delay, that feedback loop is there. So this is a sequential circuit. So asynchronous sequential circuit, synchronous means that all the devices are connected uh, synchronously. So when it will be triggered, at the time all the devices are getting triggered. That is synchronous. Okay, asynchronous that one by one the device will be getting triggered. So this is asynchronous sequential circuit characteristics. Do not use the clock pulse. So they saying this asynchronous sequential circuit do not use clock pulses. The change of internal state occurs when there is a change in the input variable. Okay, then memory element are either unclocked flip-flop or time delay element. So they saying the synchronous sequential the circuit they have used the clock pulse, but asynchronous sequential circuit they don't use the clock pulse. They often resemble combinational circuit with the feedback. Actually, there is a feedback is there. So if it is feedback, there is a sequential circuit. Then there is no clock that is called as asynchronous sequential circuit. If there is a clock with the feedback circuit, they're saying that is a synchronous sequential circuit. So here they given synchronous and asynchronous. The main difference is they have the feedback path, but there is a clock that is synchronous, and they have the feedback path, and there is no clock signal that is called as a asynchronous sequential circuit. So synthesis much more difficult than synthesis of clocked synchronous sequential circuit. So it's much more difficult compared to clocked synchronous sequential circuit, and they are used to when speed of the operation important. Actually, this is used for when the operation of speed, wherever the speed is important, they used asynchronous sequential circuit. So this is basic analysis procedure, transition table, how they will be. Actually, this is basics asynchronous sequential circuit. How we can say this is asynchronous sequential circuit, because there is a feedback path and there is no clock signal, so this is called as asynchronous sequential circuit. So this is for the expression. This is a equation for Boolean expression y1 and y2, and present state, total state, and next total state, and stable total state. Okay. The present state, the diagram y1, y2, and next state capital Y1, y2, and stable state whether it is yes or no. So this is small y1 and y2 is input. The output connected to the input. So this is a feedback loop and there is no clock. This is called as asynchronous. And y2. So based on the state table, they just put it 0 0, you know, the values they given 0 0 to 1 1, that means 0 to 7 the binary values, and y1 y2 the value they get it. um, so this is map for capital Y1 and map for capital Y2. So capital Y1 map, so this is capital Y1, so 0 0 1 0 1 1 0 1. So it's like K map, you know. So for the K map, they like capital Y1. This is for Y2 for K map. So you have to combine this binary value to this is If you combine that, this is, we can say this is a transition table. So y1 y2, so if you combine that 0 0 0 1 1 1 0 1, so this is 0 1, then 1 1 1 0 0 0 1 0. So this is transition table. So here, the value 0 0, so uh, this is state. So input and the state, output state, both the same. Just put the circle, and here also 0 1. The then input state also 0 1. So put a circle, then output and input same. Here also 1 0. So this is transition table. So the circle, the circuit has a four stable state. So whether the circle four stable state, that is 0 0 0. This is a place and this is a place. They return using map wise. Then for unstable state, 0 1 1 1 1 0 0 0. So for the K map, they return the states values. So this is transition table and flow table. So same table is there for 0 0. They put it alphabetic letter A, B, C, D like that. So similarly here also A, 0 1 B, and 1 1 C, and 1 0 D. Like that they just change the value as the alphabetic letter. So that is called as flow table. So similarly same input and output is there. So circle is same. So this is also we can call as a primitive flow table. Uh, so previously this is transition table and this one is flow table. So if they used alphabetic letter, so transition table and a map for the output. So this is basically analysis of the circuit. You see this example, asynchronous sequencer circuit. Describe the following. Okay, the given the value y is equal to some value z. There are two equation. The first one is draw the logic diagram and derive the transition table output map and describe the behavior of the circuit. So here, first of all, using this Boolean expression, we just draw the basic logic diagram. So x1, x2, this is x1, x2 AND gate plus x1 plus x2, there is OR gate, and y. Here also output is y and input is also y connected. So there is a feedback loop because both side is y is there. So output connected to the input because this one is AND gate. Okay, x1 plus x2, so this r and AND is connected here, so the total place is connected to r gate. So this is basic logic diagram. So we drawn the logic diagram of the circuit and derive the transition table and output map. So first of all, basic, this is the present state and next state. So present state means what are the input. So y, x1, x2, that is the input, and then next state, that is y output, and stable state whether it is yes or no, whether it is stable or not. So input 0 0 up to, so we are writing here 0 0 0 1 1 0 1 1. So everything they written. So what is next state? Whether we are applying 0 0, what's the value of y? So whether it is 0 0 0, so the output you will be getting next state, that is y here. Okay, and then the final is that the next that the final output. I think this is and this is will be same because here y and z are both are equal. So same value will be coming here, whether it is stable or not. How we can say that is stable or not? Um, okay. Okay, see, there is a value for next state. If it is high value, they saying no. If they get it low value, that means that is yes for stable state. So they written like that. So here the transition table. So the transition table get it from that output values x1 x2, this is the input, and three variable k map. So this is nothing but the output of the y or z. So 0 0 0 0 1 2 0 1 2 3 4 5 6 7. So like that, they will get the value 0 0 1 0 1 So 0 0. Uh, so so this is 0 1 2 3 0 1 2 3 4 5 6 7. Okay, so 0 0 1 0 and then 0 triple 1 0 triple 1 they return. So here the stable state, the whether it is 0, it's a input state, same value is there, they have to round it. So this is transition table. Similarly here is 1, same value is there, just to round it. So the round up value circle represents stable state. So there's a there's no circle, there's an unstable state. And output mapped, so you just put it whether it is unstable, put hyphen. So this is output map. So it is easy only. So basically it is stable means just round up. If it is unstable, no need to round up. So whether it is unstable state, put it hyphen, that is output map. Okay. So similarly, another example, there are three equations here. Just to draw the diagram, it is easy. Just to draw the diagram and put the state table. So input is the next state, whether is stable or not. Okay. So then and transition table. So based on the y1 and y2, you have to draw the map. So like k map. So using this 0 0 0 1 1 0 1 1 to 0 to 15, use this. Then 0 0 means, so it's the same value is there, just put the circle. 0 1, if it is same value, put the circle. 1 1, put the same value. So the circled representing stable, otherwise it is unstable. So wherever circle is not there, put it as hyphen. This is our output map. Okay. Then so this is another example. So there is a circuit, and from the circuit they have the equation and the state table, and for the map, y1 and y2 they have the map, and finally they combine the map, that is transition table. So that input and output they have to put the circle. So if it is circle, it is stable. There is no circle, that is unstable. And flow table means you just put the alphabetic letter. So that's it. That is flow table. Okay, thank you.